Hi, welcome to Send to Print. Today we're making a snap fit pin for rotating connections. At first I thought this would be a quick little model, and technically the first version did work. But the more I tested it, the more I realized it wasn't that simple. So I ended up going through 5 upgrades to make it smoother, stronger, and more reliable. So let's jump right in. This is the snap fit pin I designed for making rotating connections. It has a center shaft and 2 pairs of snap hooks, 1 pair on each side. It works like a small cantilever snap fit joint. The flexible hooks bend inward as the pin enters the socket, slide along the ramp, then spring back when fully inserted. That snapback is what keeps the pin from falling out. The 2 parts attach to opposite ends of the pin, and a small clearance around the shaft lets them rotate freely. In simple terms, the cantilever hooks flex to go in, the hooks hold it in place, and the shaft becomes the pivot. So no screws, no nuts, no metal shaft. The entire joint is 3D printed as a single piece. Let's throw it into the slicer. The footprint is tiny, so it needs a brim to stay stable on the build plate. Here it is. The brim peels off pretty easily, and the bottom is a little rough after cleanup, but that should not be a problem. Let's see if it works. It snaps in, holds the parts together, and still lets them rotate. Well, it is already a usable snap fit pin, but a working part is not always a durable part. The real question is how to make it print cleaner, feel smoother, and survive repeated use. In this orientation, the hook flexes across the layer lines right where the snap is doing its work. The test proves exactly that. I barely press it, and the hook splits right along the layer line. So the first upgrade is print orientation. To print the pin on its side, I need to shave off a small flat area so it can sit cleanly on the build plate. This orientation also makes for a cleaner print. No brim, no tall skinny part, and no overhang issue. And here's the result. No brim to peel away, and the surface comes off much cleaner. The rotation still works. Now, what we really care about is strength. I am pushing much harder now. The root of the hook has started to deform plastically, which means it is no longer springing fully back. But it has not snapped off, so it can still work, just with a looser feel. This is the first big payoff. The vertical print suffers a brittle failure because of weaker z-axis strength, while the horizontal print deforms instead of snapping off. For a snap hook, that matters because the cantilever has to flex for the mechanism to work. So version 2 is already much tougher just because the layer lines are now working with the stress, not against it. And now, the next weak point shows up. The root of the hook. A sharp transition concentrates stress, so I added a large relief radius to spread that bend over a smoother shape. I also added small chamfers to the bottom edges. That helps prevent elephant's foot, which can leave a sharp lip and make the rotation feel scratchy. Here is the upgraded version. Same material, same idea, but with a smoother stress distribution. Let's test it. This time I am really pushing it. Compared with the previous version, it takes a lot more force before the hook reaches plastic deformation. Yes, it can still fail at the weak point after extreme bending, but the radius makes cracks harder to start. In simple terms, a rounded transition removes the sharp corner, which acts like a pre-made tear line. Now that our pin is much stronger, the next upgrade is to make assembly easier. Right now, both the lead-in angle and the retention angle are 45 degrees, but a snap fit should not feel the same in both directions. On the way in, we want a smaller lead-in angle, so the hook can be compressed gradually and slide into the socket more smoothly. On the way out, a bigger retention angle gives the hook a stronger stop. So I changed it into an arrow-like profile, a gentler lead-in angle on one side and a steeper retention angle on the other. Here are the 2 versions side by side. This one uses 45 degrees on both sides, and this one uses the arrow-shaped profile. The 45-degree version feels tighter going in, but it comes back out fairly easily. On the arrow-shaped version, the shallow ramp makes the insertion feel smoother. But when I pull it out, I can feel a stronger catch. The hook is only half of the experience. To make insertion smoother, the socket needs to help too. So I added chamfers to the socket and also to the top and bottom edges of the mating parts. This way, the pin does not have to be perfectly aligned with the hole. The chamfer catches it and guides it in, almost like a tiny funnel. Here are the two versions, one without the chamfer and one with it. Let's try them. Without the chamfer, I have to line it up carefully. And this one has the lead-in chamfer. I only need to aim roughly. Once it touches the opening, the socket guides the snap fit pin into place. So the final design comes down to a few key details. The print orientation controls strength. Printing it on its side makes the snap hooks much stronger, and you won't need to add brim during printing. The fillet lowers stress concentration at the root of the hook, so cracks are less likely to start there. The hook angles control the feel. The lead-in angle controls insertion force, and the retention angle controls how hard it is to pull out. The lead-in chamfer on the rotating part makes assembly smoother by guiding the pin into the socket. And finally, the thickness and length of the snap hook control how stiff the hook feels. A thicker or shorter hook feels stronger and tighter. A thinner or longer hook flexes more easily and feels softer. So this is not one simple shape. It is a set of small design choices that work together. To make this easier to reuse, I uploaded the model to MakerWorld. It includes the snap fit pin and a matching socket cutter, which is the negative shape of the hole. Use it as a Boolean cutter, and the socket will already match the pin. Now let me quickly show you how to use it. So these are the two parts I want to connect. I'll cut one matching socket into each part, then use the snap fit pin as the connector between them. First, make a copy of the socket cutter and merge it with the part. Then select the socket cutter only. Use the Move tool to place it where the pivot should be. Be careful with the Z-axis position. Move it until the circular edge lines up with the mating surface. This is where you can fine-tune the fit. If you want a smoother, freer rotation, raise the socket cutter slightly so the cut is shallower and the parts have a little more room to move. If you want a tighter connection, move the socket cutter a little deeper. That reduces the gap and makes the joint feel more snug. For the default setup, I will align this edge flush with the mating surface. Then run a Boolean cut. And there you go. Repeat the same Boolean cut on the second part. Once it has done its job, just delete it. Now we can print the two mating parts and the snap fit pin. Alright, the snap fit pin and socket cutter are free to download on MakerWorld for everyone. And, as usual, channel members get early access to this video, plus a cheat sheet with the key design principles, and a behind-the-scenes Fusion file showing how the pin was built. Okay, that's all for today. If you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.